Welcome to this video lecture. Myself Atul Kumar, working as a assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Joginder Nagar. In this video lecture, I will discuss about DBMS architecture. So DBMS architecture is a framework or a model where the structure of the DBMS is described. So the main function of DBMS architecture is to provide user with abstract view of data by hiding certain details of how data is stored and maintained. So it hides the some details of the data, how data is stored and maintained, and just provide the user with some important detail. So this is called as abstraction in DBMS architecture. So modern commercial DBMS are based on ANSI Spark architecture. ANSI Spark is American National Standard Institute or Standards Planning and Requirement Committee. So three level DBMS architecture is based on ANSI Spark architecture. So it has three levels. One is external level, other is conceptual level, and the third one is internal level. So this diagram illustrates the three level DBMS architecture. So we have this one is the topmost level is external level, or in the external level we have end users. Then we have a conceptual level. So this one is a conceptual level, and the third level, or it is a internal level, that describes the internal structure of the database. And we have only one conceptual level for each DBMS architecture, and we have large number of external views or external level for each DBMS architecture. So the main objectives of these three level of DBMS architecture includes, so different user need different view of data of the same data. Suppose in case of our college system, we have clerical staff. One clerk have access to just free level database of the student, other have access to examination level of the student. So different users have different view of the same data. So this one is the first objective of three level DBMS architecture. The next objective is user should not worry about the physical implementation and the internal working of database, such as data compression, encryption techniques, etc. So internal structures of the database can be unaffected by changing to physical aspects of the database. So if we change the physical layer of the database, so internal structure should not be affected by these physical aspects of the database. So the first view I have discussed is external view, and it is the highest or top level view of the data abstraction or DBMS architecture. So it doesn't have any knowledge of DBMS software and hardware or any kind of physical storage. So it is concerned with the user or external users. So in case of external view, it describes the part of the database that a particular user is interested in and hides the rest of the database. For example, if we have a accounts department, so accounts department in case of university, it is only interested in student fee detail. So other important details of students like marks and examination, it will be hidden in case of accounts department. So other important details like personal information is also hidden from the accounts department. So there can be any number of external views for database. So here suppose we have n number of external views for a database, where n is the number of the users. So we have any number of users that can access the database based on their requirements or needs. So all the database users work on external levels of DBMS. So the main languages that are the main languages used in external view are DDLL, that is data definition languages, and due to different or separate views for different users, the chance of security breakdown is minimized in case of this kind of DBMS architecture. The next view is the conceptual view, and this view is in between user level, that is the external level, and the physical storage level that I have shown you in the diagram. We have a conceptual level, and it is in between external level or external view and internal view. So there is only one conceptual view for a single database. So we have many number of n numbers of external views, but for each database we have only one conceptual view. It hides the details of the physical storage structure and concentrate on describing the entities. Entity is a real world object like a car, house, people, etc. Data types, what kind of data we have to insert in the data, and the relationship and the user operations and constraint, what kind of instruction we have to impose on that kind of database. All this is in conceptual view of DBMS architecture. Also it uses DDL languages for the creation of conceptual view. DDL is data definition languages. The next or lowest level is the internal view, and it is also a physical view. It is also called as physical view. It is the lowest level of data abstraction, and it has the knowledge of software and the hardware. So at this level it keeps the information about the actual representation of the entire database, that is how the data is stored in the disk or hard disk in the form of records or block. So it is very close to physical storage method. So in case of internal view, it tells what data is stored in the database and how the data is stored, what kind of data structure, what kind of physical implementation we have used in storing that kind of data. All that details are in internal view. So internal view doesn't deal with the physical devices directly, but instead it views a physical device as a collection of physical pages and allocate space in terms of logical pages. So it basically deals with the storage space allocation, it deals with data compression and encryption techniques. It also deals with access path, that is primary and secondary keys in case of relation databases, indexes, pointers and sequences. So this one is the example of three level DBMS architecture. So the first is external view. We have different, this one is a one view, this one is another view. So this user is only accessing only employee number and employee name. The second user is accessing employee number, employee name, salary and department number. And I have discussed that we have only one conceptual view for each DBMS architecture. So this one is the conceptual view. So we have in this conceptual view we have a employee table and different kind we have this employee table as a entity, how the entity is defined and how the relation it related to other entities, all are in this conceptual view, and it is also called as global view. The next is the internal view. It is hidden from this external view, and it gives you information about storage space allocation, how much storage is required to store employee number, employee name, how it is stored, how much length is required for storing the employee name, and how much decimals are required or how much numbers are required before a decimal to store a salary. These kind of informations are all in the internal view. Next topic is data independence. So the major objective of three-level architecture that I have discussed is to provide data independence. So what is data independence? It is the property of the database. So if we make changes in any level of schema then of the database, then the schema immediately above it would require minimal or no need to change. This means, suppose in this case, if we have changed some important characteristics of this scheme internal view, then it does not affect its above level, that is global view or the conceptual view. So we can make changes in the view level that and without affecting its above level. Suppose we want to change this conceptual level, so it will not affect the external view, and this is called as data independence. So we have two type of data independence in case of DBMS. We have a logical data independence and we have physical data independence. So in case of logical data independence, it is the capacity to change the conceptual schema without having to change the external schema or external level. So we in this case of logical data independence, we will change this conceptual view and without changing this external view, and this kind of logical independence or data independence is called logical data independence. So in this figure, this one is a external level, and in external level, suppose we have and this one is a internal level or conceptual level. We have changed some we have just added salary in this, and it does not affect this external view. So the next type of data independence is physical data independence. So in this it has the capacity to change the internal schema or internal level without having to change the conceptual or external schema. So we will change the internal schema and it will not affect the conceptual or above external level. So change to physical schema may be necessary to improve the performance of the retrieval or update, or if sometimes due to hardware updations we need to change the physical schema, but due to hardware change it does not affect the upper schema, that is conceptual and the external schema. For example, suppose we have to change the location of the database from C drive to the D drive in our computer system. So if we change from C to D, so it will not affect conceptual or external view of the database. So achieving logical data independence is more difficult as compared to physical data independence. The reason behind this is that application programs heavily rely on the logical structure of the data they access. So thanks for watching this video lecture.